Good morning, everyone, and welcome to this webinar on robotic machine tending. Thank you for being here. We would like to get started. The presentation for today will be so we will have a presentation from Yaskawa Robotics first, followed by a presentation by OnRobot, and then a presentation by MELSS. And we will have all the question and answer session towards the end of all the presentations. To start with, I would like to introduce Mr. Alok Pandey from Yaskawa. And Mr. Alok Pandey is the AGM Automotive Sales. He's an MTech in Design and Development from NIT Warangal. He has 15 plus years experience in robotics automation. Over 9 years, right from design. Yeah. Alok san?
Yeah, hello, sir.
Yeah.
Yes, sir. Actually, your voice got break. So can I start?
Yes, please go ahead. Yeah, thank you.
Okay. So thank you, Srinivasan, for your brief introduction. And so I would like to share my file. 1 minute. So this is visible, sir?
Yes, Alok san. Yeah, it's visible. Please go ahead.
So thank you. So first of all, I would like to thank MELSS Automation, who has given us the time and for this particular presentation. So first I will start with our Yaskawa journey. Like Yaskawa is celebrating 107-year anniversary for this particular year. So when we talk about Yaskawa history started in 1915. Our Yasukawa-san has started this company. This particular time, Japan used to have a lot of coal mining industries and all things, but whatever the motors is there, it used to come from abroad or outside from Japan. So Yasukawa-san decided to make a particular this kind of industry where like we can able to produce the motor. So 1917, we have sold first motor with a 3-phase induction motor. So we started with the motor in 1917. And then we have moved further in 1915-8, we have developed the inertia motors. And 1969, Yaskawa has come up with a word which is mechatronics. And that Yaskawa has registered mechatronics word in 1972. And Yaskawa started working on mechanical and electronic equipment together working. And 1977, Yaskawa has come up with a 1977, Yaskawa has come up with his first all-electric robot, and this is the first electric robot of Japan. And then further, Yaskawa moved further in terms of the AC drive development, AC servo motor development, and different kind of industrial robot development like dual hand robot, arc welding robot, collaborative robot, glass subtract robot, semiconductor buffer handling robot, environment and energy equipment, and then medical and robot welfare equipment. Our vision of 2025, as our core is mechatronics, we are working with mechatronics and clean power with the help of our AC drive and AC motors. We want to give the society clean powers, and then humatronics, as we do have a product which is related to the medical and welfare robots. So where like our mechatronics and human body both are working together. So our particular aim to move further with the humatronics also. Then we talk about some facts like, as I already told, Yaskawa Electric Japan developed in 16 July 1915. And when we talk about our physical air turnover, so this is like 479.1 billion N as a basis of February 2020. And when we talk about Yaskawa India, we came in India from 1980, but Yaskawa India Private Limited with this particular company name, we are there from 31st August 2010. And our total turnover till last year is 4.3 billion INR. When we talk about robotic shipment, globally till now we have sold 5.4 lakh unit in terms of the articulated robot automation, where like 57% our sale in Asia, 18% in Japan, 13% in USA, and 12% in Europe. As we are a global company and we are having a base and our footprint in more than 13 countries, and we are having approximately 19 manufacturing units on different countries. When we talk about our Yaskawa India leadership team, so our Akinori Orakawa-san is our chairman and president. Salen Salvi-san is our CEO and vice president. Ajay Gurjar-san, who is taking care of our robotics division, he is a director and CEO. Omri-san as a CFO, Hidetoshi Maeda-san as a CTO, and Sanjay Tiwari-san as a deputy CEO for robotics division, and Bhavani Shankar-san is working as a drive and motion operation head. When we talk about Yaskawa India journey, so as I told, like we started in India 1980, and that particular time Larsen and Turbo is our distributor, and we have one PLC product which is called Memacon PLC. With that, we have entered in Indian market. And then further, Larsen and Turbo has carried on our distributorship, and they used to sell our AC drive and robot also. Then 2005, we have established this Motherson Group, Motoman Motherson India Private Limited, and 2008. Like further our service and other facilities like Bangalore and Pune, we have made it. In 2015, we have celebrated 10 year of our robotics facility and 100th year anniversary of Yaskawa Electric Japan. 2016, in India, we have assembled approximately 1 lakh drives in Bangalore facility, and 500 plus robot we have sold in a 1 year in 2016. And but if you see in the 2021 as a last year, so here the quantity is 500 plus robot, but when it comes over 2021, we have sold 1000 plus robot in 1 year, where we have a single robot order, single project of 300 plus robot from Tata Technology. And this particular current year, we have upgraded our all the regional facilities and head office. I will give the glimpse in the future PPTs. Now, when we talk about Yaskawa in India and our presence, so we are available at all major locations. So Bangalore is our registered corporate office, where we have a manufacturing unit for drive and motors. And Manesar is our robotic factory. There actually our robot comes from Japan, but we do manufacture some add-on access kit or positioner kind of thing. So that's why we use to tell a robotic factory. And we do have an office in Ahmedabad, Mumbai, Chennai, and Pune. So with this particular things, we have one head office, one robotic factory, 5 regional offices, and 7 number of sales office or residence engineer kind of things. Till our H1, we have installed 8,500 plus robot in India in terms of the number of quantity. So this is our facilities. When you see our Pune office, so Pune office, we do have a right reception and all thing and demo and trial setup. This Manesar facility. This is recently only we have developed and we shifted here. And in the Manesar facility, we do have an experience center. Below you can see the particular video. So here we have actually all kind of application when we talk about assembly, arc welding, painting. Then you move further for the spot welding, collaborative robot with palletizing, and machine tending application. So we have exhibited the all kind of applications. So anytime customer can come and able to see like how robot are working with the different applications. And then these are Bangalore pictures, Chennai and Ahmedabad. Then we talk about like from last 100 years, we are working in this particular field. If you have seen, our first product is motor, and still we are dealing with the motors, and the motor we have refined. From motor we have gone with the drive, and with motor and drive combination we have gone with the robot. So we are having 100 plus year experience for this dedicated technology. When we talk about what we given to the world, we started first transistor AC drive Yaskawa has developed and given to the world. For Japan, first all electric robot Yaskawa has developed and given to the world first time. And world smallest and lightest frequency response by 250 hertz drive and all things that is developed by Yaskawa long back first time. And when we see about like all people tell like one controller can able to operate the 6 robot, 7 robot. So that actually a first technology is developed by Yaskawa, and they are like from one controller we can able to operate multiple robots. Then we move for the dual hand robot, smallest robot of the world, and then further for GN kind of motors. So as I told, like we are working on our key technology and core only. So like robot, motor, and drive. This is our 3 specific products. So I will come in detail in the further slides. So As I told, 100 plus experience from when we started in terms of talking about motors, and we talk about the robots, we are having 45-year experience in robot. In 1977, our first robot with Motorman L10, which we have developed, and currently our YRC 1000 series is going on, which is got launched in 2017, which is equipped with the Industry 4.0 solution as a by default. So this is as the basis of industry and different market size. So when we talk about industrial robot for automotive and other market, so like this arc welding, spot welding, painting, pick place palletizing, handling and press robot, and few clean room robots for semiconductor and FVD industries, and collaborative robots and dual arm robots. So these are different range. We are having approximately 175 plus robotic variant in our product range. These are few popular model only, which I have just shown here. And this is our drive. When we talk about AC drives, so we have a like general purpose drives, regenerative drive, application specific, low harmonic drive, and regenerative braking unit. And with the help of also further for servo motors, Sigma 7, Sigma 5 series, and MP300 3000 controller for operating the motion and control. We do provide some solution, but this is like a standard product. So as a standard product, as I told, like few manufacturing we are doing in the Manesar facility. So this is like our positioner PS500, PS500C, and 3-axis positioner. We do press automation, handling business, and handling business like with our partners like MELSS Automation and all things. We work on the machine tending, vision-based application, part tracking, stacking, and end-of-line palletizing. Now I just want to give the glimpse about our arc welding robot. Of course, this presentation related to the machine tending, so I will go deeply in that, but I just quickly run through about our arc welding product range. So we have from 700 reach to 3120 reach robot, where like our 700 900 reach robot is a solid shaft robot, and 1440 to 3120 reach robot is a hollow shaft robot, which is widely required because we require good orientation in the arc welding situation. So that's why we have developed all the range with the hollow arm robots. And as we are giving the complete solution to not only robot, we also providing the welding power source. So as the basis of requirement of different industry, we are having a basic welding power source like SR350 and SR500, and mid-range power source X350 and X500, and top end power source which is like very low spatter and high speed with X350 with Eagle technology. It's used to have a servo torch, and X500 with Eagle technology. And as you have seen the video, like we do have a spot welding robot. So they're like different as the customer requirement. So for few customer, space is a more concern. So for that we have a SP80, SP110. This is a very compact robot. And for few customer, like initial price is important. So we have SP165 and SP210 robot, which is too much popular in our Indian market. And some customer really want to work out like maximum payload and all things with minimum space they want to use. So we have worked out for the hollow shaft robot in 180 kg payload and 235 kg payload. Our all robot used to come with the IP67 wrist, and also whatever our all range of robot is there, it's used to have a single cable. And the biggest part is that if you see the robot used to have a 6 motors. In the 6 motors, each motor normally, if you see the machine tending operation and all thing particular, some 2 axis is working more. So what happened? Maybe the 2 axis particular encoder cable may get faulty. So what happened? People has to change the complete harness. But in our case, we have a multi-drop concept. So whatever motor cable have gone, only person has to change that particular cable. And then is our handling robot range. So we are having a two kind of range in a handling robot, where like we are having till 25 kg. So there is from 300 gram payload to 25 kg payload. Our robot range is applicable. So we're like Moto Mini, which is smallest robot. This is like we can take by hand and we can move one place to other place. Then GP7, GP8 is a high speed pick and place robot, where like in your machine tending, if you are having a very critical cycle time, 15 seconds something, then normally we can utilize this kind of robot, GP7, GP8. And GP12 and GP25 robot. This is also hollow shaft robot. So all the cables and everything will be routed from the robot inside only for the machine tending operations. And when I talk about this particular GP7, GP8 robot, these all robot comes with the complete body IP67, and our all robot used to have a coating of anti-corrosion coating, which is really required for the machine tending environment. And then other than this 25 kg, we do have like 25 to 600 kg payload robots. So different size of products are available in that. The detail of this different variety of range is available. So like in this, we have a 6-axis with hollow arm, 7-axis with hollow arm. So they're like different payload, like GP50 normally required for very high speed and rigid environment. So we are going with GP50. Sometimes customer required very heavy payload and very compact robot. So that's why we are having GP200S, which is like very compact and very small robot, but its payload is 200 kg. Normally, if you see in market, the people are having a robot like 200 kg, but reach is approximately 3 meter or something like this. So that's why we develop the very compact robot, and this is also really useful for the grinding, buffing, and these applications. Then further, when we goes for the product range, when we talk about 110, 110B, 110B is 7-axis robot. Why is required in machine tending if you are having a two machine very nearby and you don't have a space for robot? So in this particular 7-axis robot is something like this, which can touch his bottom also. So this particular 7-axis robot, which required very small footprint and very less internal reach. So we can able to save the space for the customer. And then further like GP 180, 225, 280, and at the basis of payload of the component, we can move further and we can go further with 600 kg payload. Now, when we talk about machine tending, I just talk about few brief about our all product. So the machine tending, when we talk about robots, we do have a robot solution, and so we are supplying to MELSS, and MELSS is integrating further and giving the end-to-end solution to the customers. So we have for this machine tending, we have a GP series and human collaborative robot, which is normally popular for machine tending. Our human collaborative robot is with also with IP67, so it can be used with the coolant kind of atmosphere. Then we talk about the gripper. So gripper normally machine tending, two kind of gripper is popular, like traditional and integrated gripper. So traditional gripper, whatever earlier pneumatic gripper used to come, and now integrated gripper. So like what kind of gripper OnRobot supplying, which is totally integrated with the all kind of robotic controllers. And our controllers used to come, as I told, with the Industry 4.0 solution, and further required the machine tending feeder and total logic control, for which we are having in our robot as a Ethernet IP. And if customer don't want to use PLC, then we are having our logic control also separately with that. Then further for like either picking or inspection, we require vision in the machine tending. So our robot is having a standard interface with all kind of smart vision camera supplier. So basically, this is the brief and why robot is required for machine tending. Basically, when we talk about robot provides the safety, because when man is working, because only CNC machine is not a machine tending. When we talk about CNC, injection molding, die casting, press, these all the machine. And then with that, in a lot of places we get the safety constraint and consistency from the machine operation, we are not getting it. So that's the main purpose for which we have to go for the machine tending operation with robotic automation. And why Yaskawa? We are fully supported robotic solution with our partners that can greatly simplify the robot deployment, reduce the cost of the of our offer, and the option for the machine operation. So this is just one a glimpse about or one layout with the robotic automation, where like one robot with the two machine is getting interface, and here like this robot is there on common base with the feeders. So like anywhere you can take out this particular system and you can interface with your any kind of machines. So when we talk about machine tending solutions, like one glimpse used to comes like is for automotive, but is not only for automotive. It's having a different kind of market like automotive industry, transport industry, medical industry, and construction industry. So in this all kind of industry, Yaskawa has given the robotic solution for machine tending operations. Then this is some glimpse about the few machine tending projects, where like if you see at the base of cycle time, we have gone for the one robot and the one machine concept. There is a concept like one robot with a two machine concept, where this normally popular for the gear manufacturing industry. Then here also like one robot with three machine concept. Here is a one robot with a four machine concept. So at the base of cycle time, adaptability, layout, we have a huge range, as I told, from 300 gram to 600 kg payload, from 500 reach to 4-meter reach payload. So you can able to adopt our robot at the base of cycle time wherever Azon is required. And there is also some more glimpse about the like one robot with three machine and one robot with the three machine. And as I told, like they are also required the feeders. So when we talk about the feeders, so different kind of feeders will be applicable. Like one is a subtle kind of mechanism. This is a multi-story subtle mechanism. Here, if you see like this is a rack kind of arrangement where we can able to put the 4 to 5 kind of racks, and whenever variant is changing, you just has to change the top plate, and after changing the top plate, it can be adopted with a new variant. Then if you have a gear kind of thing, so a small turntable with the feeder mechanism, this like output feeder, and this subtle kind of input feeder for circular object. So I just want to give the glimpse about some infeeders and outfeeders, so that's why I put it this. Another, there is a n number of outfeeder and infeeder concepts are available with us. And as I told, like in the machine tending industry, we do require the visions. So we are having a dedicated software for that, which is MotoSight 2D, and this work with the 2D vision. So any kind of camera can be interfaced with MotoSight 2D, and then we do have a MotoSight 3D. So wherever like bin picking is required, we are having some rough locations where like one above the other, we are having a component. So with this, we are working out and we are having a MotoSight 3D solution. So it can be interface. Of course, for this particular case, we required first trial should be conduct, because there is a lot of component which cannot be covered with MotoSight 3D. Then till now I've just gone for the CNC machines, but now I would like to touch up the point of injection molding machine. So when we talk about injection molding machine, these are analysis done by Automation World in 2021. Like articulated industrial robot are directly proportional to the flexibility. So when we talk about our all product range, maximum product range is having a 6-axis articulated robot, 6-axis collaborative robot, and SCADA robot. So when the analysis is done, what kind of flexibility and all robot is having. So when in the case of injection modeling, machine tending can be done with all kind of robots. Horizontal press, pick and place or extract the part can be done from the robots, but vertical press, pick and place or extract the part vertical way, that cannot be done by the Cartesian robot. That can be done with a 6-axis robot or collaborative robot or SCADA robot. And further move for the our insert molding, over molding, these all things possible with the 6-axis robot only. And trimming, decating, finishing, inspection, assembly, packing, sorting, and palletizing. These all applications are possible with our 6-axis articulated robot. So when we talk about in machine tending, normally some people are using gantry, some people are using robot. But basically, when we talk about flexibility, if customer want the flexible solution, we should move further with the 6-axis articulated robot. This is a product range, like how we are mapping a different kind of tonnage of injection modeling machine with our robots. So when we talk about our 50-ton machine can be able to cover with the GP7 and GP8 robot. And then for this goes with the 150-ton machine. So there we have a model like GP8L and GP12, where the 8 kg payload and 1.6 meter reach, 12 kg payload, 1.4 meter reach. And so the below the range, which is like where we are mounting the robot front of the machine, floor mounted. Above the range where we are mounting the robot top of the machine as a self-mounted robot. So there is a customer have a requirement like they want self-mounted and they want the floor mounted. So at the basis of that, we are having a solution and mapping for the different machine. So when we talk about like intermediate machines can be done with the GP50 and GP35L. And when we go for the 2500-ton machine, so we have our GP180, GP180-120, GP225, and in term of the self-mounting robot, GP165R and GP200R. And when it's come for the very longer reach robot, which is required normally for 4000-ton machine, so we do have GP120R, which is approximately 120 kg and 4-meter reach robot, and similarly GP400R in term of the floor mounting robot. So this is something like this. If you are having any tonnage of machine directly, you can pick up the robot, just a small simulation, we can do it for confirmation and you can move further for this. And in this kind of injection modeling is become automation is become very cost effective. The reason behind that this like all injection modeling machine used to come with a Euromap interface. So when the machine comes with a Euromap interface, so we do not require any kind of add-on PLC and all things. They're like the direct communication between the robot and machine can be done with the SPI 67 interface. So this SPI 67 interface having an electrical part, connector part, and third is a mechanical mounting part. So electrical part, this part will be mounted in our controller and directly is going towards the machine through this particular hurting connector, because this connector always available in the all injection modeling machine. So with this particular concept, just directly with the hard wiring and dual channel safety, we can able to provide for injection modeling machine. So there no huge cost is going to come in terms of the automation. And the third portion, when we talk about press, the press also come as a for machine. And in the press automations, we have a fastest robot like PH130F, PH130RF, and PH200RF. Why we do have a different product range for the press robot? Because when we talk about normally in market, whatever the press is available in the H press normally work on the flywheel speed of 24 to 30 SPM, and start stop mode they used to work on the 12 to 14 SPM. But when man is taking out the production on the H press, the your press capability is 12 SPM to 14 SPM in start stop mode. But with the manual labor, we can able to take out 6 to 7 SPM only. So in that particular case, instead of if customer want is if customer having a 3 press line, so it's better to instead of increasing 1 press line, he just automate 2 press line. He don't have to invest on the 3rd press line, and each press will cost too much. And in the within the cost of 1 or 1.5 press, cost of 1.5 or 2 press, we can do the robotic automation, and easily we can able to save the cost. And we have installation approximately 20 plus press line in the India, where approximately 120 plus press robot is working. This is a one small glimpse about the press line, how it used to have, like it used to have a destacker unit, centering unit, and then robot used to do the pick and place. And then between the press machine, there's an intermediate transfer will be there and end of the line. So you required one observer, and end of the line, you required one operator. You can run the line with these 3 people, 3 shift. So this is just a few glimpses for the small video I would like to show here. This is like a freight line video which is running here, and this is installed in India in SK Vitek. So this shows how robot and press machine is getting interface. Here, if you see like robot press is going up, and before that robot is going to enter inside. The second is for the heat treatment machine. So whatever the heat treatment machine is there, this is the application for the latest spring, where like robot is working the harsh environment, and this particular atmosphere is not okay for the operator. Then this is for the gear machine. So where like whatever the gear machine tending we are doing with the traditional gripper, and in this particular case, approximately 6 to 7 machine got interface with one GP25 robot. There are a lot of operation like deburring, grinding, bobbing, lot of operation is going on. And further, if you see this right hand side top corner, this is the video which is for injection modeling machine. As I told, why robot is required in injection modeling machine? Because here, if you see the particular this component, we are taking out, we are going to do the trimming operation. After trimming operation, we are going for the flaming operation. And we do have a collaborator robot, and we started working with a collaborator robot in 2017, where we came up with the SC10 YRC1000 robot, where like no safety fence and all things are required. Then further we moved our robot development, and from normal controller to be moved for the small controller and smart pendant, and also hand carry type of robots. And then further in this 2019 to 20, we have gone with the different specification of robot, like dip proof specification. So we can work in the foundry atmosphere, we can work in the machine tending atmosphere. In that particular area, we require the dip proof protection, where complete robot is IP67. And also when we are going for the food industry, so robot grease should be used as a food specification. So that's why we do launch a food specification robot. And further, like in this particular year, we are launched with the 20 kg and one more 10 kg payload robot, and further one more 30 kg payload range is came recently last month in our product range. And other than these things, like we work with the MELSS automation for the lot of palletizing projects also, so where we do have a MPP3 robot. So the MPP3 robot which can able to work approximately 200 picks per minute. Then we have an MPK2 robot with a 5-axis robot, which speed is approximately 70 picks per minute. And then we do have a palletizing robot from 80 kg to 800 kg, different payload capacity, which can able to serve to the customer or any kind of industry and any kind of atmosphere. And when the complete world is talking about the industry 4.0, so approximately in 2015, our factory has come up with the concept of IQ mechatronics. And this concept first we evaluated in our factory, which is in Tokyo. And we evaluated this complete concept in our factory, and we are using as a sample for this particular concept. In this particular concept, we work out for first I for integrated, second I for intelligent, and third I for innovative. Integrated means at whatever the down the line level machines are there, robot, servo drive and everything that we are combining as an integrated way. And then whatever our IQ controller, we are taking a database on the top the line level, and then we are doing any kind of improvement is required. And further, like innovative, when we are going further, we can able to control and all thing, and whatever this data is there that we can utilize in the innovative way for developing the new solutions. So basically, when we talk about for this, our basic platform is Yaskawa cockpit, which normally interface with the robot and collect all data on real time. Every data we are collecting real time, and then is going for the big data utilization analysis. And after that thing, further for ERP or MES, if you want to take the data, so this is on OPCA basis, so you can directly take on the data on the ERP and our MES server, and you can integrate with your top line system. So basically, when we talk about in the YCP, in the Yaskawa cockpit industry 4.0 solution, we are having a different concepts. Like in the concept, what the normally management issue is there? Management having an issue for improvement of productivity, enhance the product value, and cost reduction. So when we talk about improvement of productivity, normal challenges are there, unanticipated shutdown, shortening the cycle time, and improvement of yield rate. So for this, in our Yaskawa cockpit, we have lot of options is available. So like robot visualization function, health checker function, alarm management function, oscilloscope function, backup function, robot recorder function, robot data change function, robot torque sensor monitor function. These all functions normally required to save the robot. Means whenever in future if any breakdown is coming, so we can able to observe in future only if any kind of mishappening may happen, and we can able to take the call on right time. Then for shortening the cycle time, we to have a operation status management where like we can able to observe, okay, robot has run how many hours, some operator approves the emergency or they are not working, and also scope function where like we are just running out at the basis of that, what way our motor and gearbox is working and what kind of load is coming on the each motors. Then improvement of work quality. So we do have a monitoring functions. So arc monitoring functions, motor fit monitoring function, spot weld monitoring function, and other work monitoring function. And then traceability, because we want to trace also what all the thing is that we have to trace. So for the arc welding, we can able to trace all kind of data, like what kind of voltage current, when you have welded what component, and which kind of parameters are used. Similar way in motor fit, spot, and other monitoring function. So this is the basic about our Industry 4.0 solution. And when we talk about our Yaskawa offerings in terms of the service, in the service, like we have a 24-hour hotline support number. So anytime you can give us the call on the hotline support number, it will be answered, even is the night 2 o'clock or 3 o'clock. A field service engineer, and then we have our repairing centers in Manesar facility in Bangalore, where we do repair our robot teach pendant, welding power source, and pent robot rest. Then after the training, part logistic and robot lifecycle management. We do have a SMS portal like this is service management portal where customer from online directly can register his query. And when it's registered, is have a TAT time within 3 days. We have to close that particular query. And when we talk about our team, in terms of the team, 31 service engineer we are having in robot and 23 service engineer we are having for our motion and control. So we carry approximately 54 service engineer to support all over India. And this is our strong customer base with the basis of our whatever the product we are having. We do have collaboration with different colleges like IIT Bangalore, IIT Madras, IIT Varanasi. So here we are having an academic collaboration. We have supplied the robot, and people are getting trained on that. Other than that particular collaboration, we had a collaboration with Tata Technology. Again, this particular initiative, we have already installed 300 robot in Karnataka, where like 150 ITI got automated. So after 1 or 2 years, you will get the trained engineer which is coming out from there. And this year we are going to supply for Tamil. This year we are going to supply for the Tamil Nadu. So for Tamil Nadu also we are going to supply approximately 150 robot where like 75 ITI is get upgraded in this particular case. And we do discussing with the Bihar government, Assam government and Manipur government for similar kind of initiative. And this kind of initiative also appreciated by Mr. Modi also when he have came in one exhibition where we have shown our this particular robotic cell which we are supplying to different ITI. And then further for the corporate social responsibility, when we are going in the market, like in the all the way, first is a skill development area, we are doing corporate social responsibility. Then when we talk about like orphan age and these all places, we are working out and we are trying to support like our Indian social societies and we want to upgrade that. So basically, this is from my side. So Srinivasan, now hand it over to you.
Yeah, thank you very much, Alok San. Thank you for the wonderful presentation. Yeah, I'm sure that a number of people have queries and questions. I'd like to invite them to kindly put your queries in the chat. We will take them all up after the next presenter's presentation. Yeah, thank you very much. Yeah, I now call upon Mr. Niels from OnRobot. Niels is the area manager for South Asia, Southeast Asia and Oceania. Niels is a native Dan who has had more than 25 years of experience in other countries and currently he resides in Singapore, and he joined OnRobot in October 2017 and was the first employee in APAC region. And he handles the partner network based out of Singapore. And Niels has a bachelor's honors degree in marketing and international management, and is from the International Business School of Groningen, the Netherlands. In the past 22 years, Niels has worked for many countries, including in Malaysia, Singapore, Denmark, and in Qatar. And he has been in Asia since 1997, so he's very familiar with all the countries in this area. And he currently handles the partners in APAC and has 15 countries and territories under which Niels handles 10 of these markets. Over to you, Niels. Thank you.
Thank you so much. Okay, let me share my screen. Are you able to see my screen or not?
Yes, good.
Okay,
yeah.
All right, okay. I think I'll just cut the camera just in case of speed issues with the internet. Let's see. All right. Right. Okay. So thank you first of all, Shiv Kumar and MELSS for giving us the options to present today. So the main theme of this webinar is basically to talk about machine tending and how to automate machine tending. So that's also where my focus is going to be today, on how OnRobot is part of that and how we can support companies wanting to automate machine tending. So first, a little bit about OnRobot. We are a Danish company launched in 2011. In the city of Odense, which is kind of like a robotics capital of Europe. It's a for Indian standard a very small city. It's about 220,000 people, but there's more than 130 robot-related companies in Odense in Denmark. So for OnRobot, we are basically a joint 5 companies, 3 companies from Denmark, 1 from Hungary, and 1 from US that are joined into one big OnRobot company. So globally, we are, as I said, we are based out of Denmark with the headquarters. We also have R&D and production facility in Hungary as well. For the APAC region, Singapore, where I'm based, is the APAC headquarters, but we also have offices in China, Korea, and in Japan as well. So as Shiv Kumar mentioned, I'm basically handling so South Asia, Southeast Asia, and Oceania. So basically from India to New Zealand is the market I'm covering. So what does OnRobot do? We are basically a supplier of, well, we used to be known as a gripper company, but basically what we are now, we are a company that assists with collaborative applications, automate collaborative applications. That goes anything from grippers to force track sensors, vision system, different kind of processing tools. We have a 7-axis lift and palletizing. We have different kind of software as well now. And software is something we are going more and more into, and you'll hear more from us in the future about different kind of softwares that we are coming up with. But today, let's talk about mainly machine tending, right? So a big part of the world, and not least places like India, a lot of machine tending is still done manually for different reasons. It could be cost, it could be, companies that are a bit wary about wanting to automate because, they don't really understand how it's done, or they're scared of, having maybe to do programming themselves, or what happens if the robot doesn't work, etc., etc. But long story short, machine tending doing manually is still, it's a very dull, i.e. boring job. It's dirty, and it's also very dangerous. So these are the typical things, where you're looking at automating things. So generally speaking, if you look globally, issues with labor shortage is something that is becoming more and more common. I mean, even in India, post COVID, a lot of companies basically lost their labor and have issues finding new labor to handle many of these manual jobs, which also creates risk of bottlenecks, right? So if you don't have staff, or staff that are becoming ill, or staff are going on vacation, etc., you might have issues where you can't keep up with supply time. As I said, safety is an issue. Having people working with machines is always a risk. So that is something you also need to look at. And because, as I said, things like bottlenecks, you might lose your staff, etc. So that can create issues with your supply chain risk, which is something no company wants to get into. It's also very hard to increase your capacity or your productivity by using manual labor. Basically, we have to increase, maybe more shift, i.e. hire more people, which means more cost. And doing things manually is basically impossible to lower your cost, because there's no way of really making it more productive. Sometimes using manual labor also means higher waste, because people do things, they drop things, or they put it in the machine wrongly, etc. So there's a lot of reasons why you have increased waste doing it manually. And again, depending on your cycle time and so on, sometimes there's a very inefficient use of your labor, because sometimes when the CNC machine, etc., is running, the person itself is just standing there and really can do not much. So you don't really use your labor very efficiently. So if you want to do machine tending by automating it, and here's an example, if you talk collaborative machine tending, what are the benefits? You have a very fast deployment time, and this is something MELSS can talk to you about as well. For instance, using the Doosan Cobot or the Yaskawa Cobot, how easy it is to set up, how easy it is to attach the end effectors or even vision system if you want that. Programming is very easy as well. This is something anybody can really learn, so you don't necessarily need an SI to do it for you. When it comes to machine tending, typically we're talking high mix, low volume. So being able to not only deploy, but redeploy very fast and very efficiently as well is important. And this is something you can do with collaborative automation. And also, because it's high mix, low volume, you keep on changing different work pieces that you work with, different shape, different size, different weight, etc. So you really need tools that are able to handle multiple work pieces without, you having to buy, for instance, a gripper for each new work piece you work with. So having that kind of flexibility is very, very important, which you get with collaborative end effectors. It's also easy to ramp up productivity. I mean, we all know robots can work 24/7, so you don't need, if you want to go from one shift to two shift or one shift to three shift, you can let the robot do the job rather than having to hire extra people, which also avoids the human bottlenecks that might be otherwise. You minimize, safety risks, and also you minimize waste, because there's really no interference by humans at all. So that's another cost saving you will have by automating everything. So I'm going to talk about an example here, how to successfully set up a CNC machine tending. So imagine those of you who are on the call today, probably the reason you're here is that you might not be doing automated machine tending yet, but it's something you're considering. So what are the things you've got to consider to have a successful CNC machine tending setup, as an example? So the first thing, of course, is the robot itself. There's a few different things you need to look at. One is speed. So maybe you have a slow cycle time, maybe you have a fast cycle time, maybe you have different machines with different cycle times. You need flexibility. So that's one thing you need to look at. What is the total payload of the robot arm? So what is the weight of the gripper plus the workpiece, for instance, and also the center of gravity? Maybe you have one gripper, maybe you have a dual gripper, maybe you have a long workpiece, so the center of gravity is far out. So all this kind of thing affects the payload. And then, of course, the reach. So the reach, from the inlet to the machine to the outlet, what is the reach needed to be able to reach all the points for this particular application? Secondly is robot mounting. Typically, we talk about 4 different ways. One is the middle configuration, which basically means the robot is placed right in front of the door, which means you need a not as long a reach for the arm, but what it does is it means that it's hard to get into the machine by a human if that is needed. So it's not always optimal. Then there's the side configuration, which basically means it goes a little bit to the side where it leaves space for the operator to access the machine. But if it just is put on straight up, then there might be a reach or there might be an issue with reaching into the machine by the robot arm itself, which comes to the side incline configuration, where basically you angle the robot arm maybe 45-degree angle, which means it gives a longer reach and it'll be easier to reach into the machine itself. And finally, which is also very common today, is a movable configuration, basically where you have a movable cart, a movable trolley, where you can put the robot on. So while it's working, it's right in front of the door to the machine tending CNC machine. And if somebody needs to get access to the machine, you just push the cart away. So that's also a very common way to mount the robot arm these days. Next is the workpiece analysis, which is also very important. So one is the size itself. I mean, that is obviously important in terms of what gripper to use. When we talk about gripper stroke, we are basically talking about the width that the gripper can open. Also the shape, is it square, is it round? That sometimes will have to do with what kind of fingertips you're putting on the gripper. Maybe also the gripper type. And then of course weight. So again, it comes down to the gripper. You need to have a gripper that can hold the specific weight of the workpiece, but also you need to look at a robot arm, as I mentioned earlier. So the weight of the gripper plus the weight of the workpiece, will the robot arm actually be able to lift that? So that's very important as well. The next thing, which is kind of where we are coming in, is the gripper. What kind of gripper to use? Typically for machine tending, it can be 2-finger grippers, 3-finger grippers, sometimes magnetic grippers, especially for picking up metal sheets. It could be vacuum grippers potentially, and sometimes accessories like different kind of fingertips, etc. For OnRobot, we offer single grippers or dual gripper setup, and I'll talk a little bit more about that in the next few slides. Having flexibility, which is what comes in when you talk about collaborative end effectors, right? So as I said earlier, CNC machine tending in particular is typically high mix, low volume. So you keep on changing the workpiece you're working with. You have freaking line changeovers and big variety in the kind of work pieces, the work shape, the work size, and the work weight that you're working with. So you really need grippers that are able to work with multiple pieces rather than you having to change or continue investing in new grippers because they can't pick up the item you're working with. So that's very important as well. And ultimately what we're offering is basic plug and produce. So you can install any of our grippers within 5 minutes to any robot really. And programming is quite easy as well. So it's very, very simple, it's very easy, and it's very safe. Then we talk about the infeed system, and Alok also talked a little bit about it before that. Generally speaking, the best way is to present the workpiece in a fixed, structured, and repeatable position. So basically, you have for instance, here like a table where you have you can set the workpieces down in a fixed position, so the arm knows exactly where to pick it up. Having it slant like this adds on gravity, so it's easier to hold the workpieces in the right position as well, which is also important. It could also be putting up a system where it's easy to reconfigure. So I don't know if you can see it here, but these have like small pins you can put in the table, which can be put in different ways, you know, for either round items or for square items, etc. So that's another way of doing it. Sometimes you might need a vision system. It could be, you know, if the workpieces continuously change, or if there's no specific pattern that the workpieces are coming in, then having a vision system is required as well. In terms of the outfit system, it's generally the same as looking at the infit system, but it really also depends on what is being done next with the workpiece once it comes out of the CNC machine. Maybe it goes to a different kind of process, maybe just going straight into a box for packaging. There's different ways of doing it. Sometimes you put the finished item back into the infit system as well. So overall, these are the kind of different things you need to look at to have a successful, in this case, CNC machine tending setup. But again, MELSS can talk more about this if you're interested in knowing about this, or you need a demo of this. So when it comes to OnRobot, what we offer for machine tending in general, there's a few different components we're talking about. One is a software. We have our Weblitics software, which is basically a remote production monitoring software that can monitor the robot arm as well as the end effector. So for instance, it can monitor cycle time, it can monitor how many pick and place is done in an hour, for instance. It can give you warnings if the application stops for whatever reasons, and you can basically optimize your cycle time and minimize waste and lower your ROI by keeping on in real time understanding what is going on with the application. The robot itself, so we generally speaking, OnRobot works with all robot brands, but here for MELSS, they are, as you might know, they are working with Doosan and Yaskawa, which we also fully integrate with these two brands. So you can easily integrate our end effectors with both Doosan and Yaskawa. When it comes to vision and mounting, we have our vision system. It's called EYES. And then we have our quick changers with our manual quick changers. We have a single quick changer for one end effector, or a dual quick changer with two end effectors. In terms of the grippers, what we typically sell for machine tending, we have our 3-finger gripper, our 2FD7, which is a parallel 2-finger gripper, our RD2, RD6, which are circular grippers, and our MG10 gripper, which is a magnetic gripper. And everything we do, whether it's the vision system, whether it's the grippers, or even our vacuum grippers, are all fully electric. We do not sell anything pneumatic ones whatsoever. So once you install our end effectors, it is basic plug and produce. You don't need to worry about air supply or etc. It's just straight in. Within a few minutes, you're ready to go. We also sell different kind of accessories. It could be X-shaped fingertips, it could be extension for the fingertips and so on if you need a longer reach, or even an angle bracket, which could be easier, you know, to get into the CNC machine and attach the workpiece. So this is kind of how we fit into the overall component scenario of a machine tending application. Now, just a few further details on the products I just mentioned. So as I mentioned, our Weblitics is basically an OEE software that helps you increase your productivity, helps you understand in real time exactly what's happening with your application. So you can optimize cycle time, you can minimize waste, you can anytime know if the application breaks down, and you can minimize repair work, etc., etc. So ultimately, it'll give you a much faster ROI compared to not monitoring your application. For our vision system, so what we have, it's not a 2D, it's not a 3D, it's actually a 2.5D camera. So if you don't know the difference, so a 2.5D is basically similar to a 2D, but it measures height as well. So it has the Z axis as well. So it can basically, if you have work pieces in different heights, you can use the camera to tell the robot how far to go down to pick up a specific workpiece, depending on the height of the workpiece. So that is, yeah, and also if you have workpieces in different shapes and so on, if it's not a fixed position, that is where you can use a vision system to help you with the machine tending application. Our RD2 and RD6 gripper, so 2 and 6 basically relates to payload, but with all our grippers, what you get is a fully flexible end effector, so you can fully set the stroke. And again, when we talk about stroke, it's basically how wide you can open. So you can have one gripper and you can pick up multiple items in different shape, different size, different weight with the same gripper. So it's a very big flexibility. You can pick up from outside in or from inside out as well. You can also set the force. So you might have, for instance, if you're doing plastic molding, you might have soft items where you don't want to squeeze too hard. So you can set the force as well, how hard the gripper is closing. So it gives you a lot of flexibility. You can change the fingertips very easily. You can buy from us, or you can make your own. You can just 3D print them, or you can make them in aluminum and so on. So it gives you a lot of flexibility where you don't need to have multiple grippers for multiple items. And of course, there's a big saving in this as well. Our 2FT7, as I said, the difference here is it's a parallel gripper. It's also IP67 rated, so things like machine tending where it's more dirty environments, it's very important. The speed is quite a lot faster than the RT grippers, and also the payload is higher as well. It can go up to 11 kilo, depending on a bit how you pick up your workpiece. And again, like all our other end effectors, we have our own software for Doosan, and even for Yaskawa, we have different ways you can integrate with our software, or you easily use the Yaskawa software as well. For the 3FT15, it's also a high payload gripper, so it's up to 15 kilo, IP67 rated as well. And this obviously is mainly for picking up round or cylindrical objects where maybe using a two-finger gripper is not that easy or it's not that safe. And the same thing here, you can fully set the stroke, you can fully set the force, you can change the fingertips, you can make your own fingertips, even the arms here, you can make yourself. If you want them longer, you want them wider, etc. It's fully flexible. So again, one gripper working with multiple items. You can pick from outside in or inside out. So again, a very high flexibility in working with multiple work pieces for the same single gripper. And like all the other grippers, you can have it as a single setup or you can have it as a dual setup. The MD10, the magnetic gripper, as I mentioned, it's also IP67. It has a max payload of 10 kilo. So if some of you have worked with magnetic grippers or are currently working with magnetic grippers, you might understand that a traditional magnetic gripper is very hard to control the gripper, right? So for instance, if you're doing machine tending where you're picking up metal sheets for machine for bending the metal sheets, it's very hard for standard normal magnetic gripper to pick up one sheet at a time. Sometimes you might pick one sheet, sometimes you might pick 3, the next time you might pick 2, but it's very hard to control. But with our gripper, the MD10, you can fully control whether you want to pick 1 sheet at a time, 2 sheets at a time, 3 sheets at a time. It's very easy to control. So it's much easier to use than a standard pneumatic gripper. And again, it's fully electric, very easy to use. So single gripper or dual gripper, what's the benefit and what's the difference? So ultimately, it typically comes down to cycle time of the machine tending application you're having. So again, using machine tending as example, here we have a timing that we are done based on a single gripper for machine tending application versus a dual gripper for machine tending application. So with a single gripper, the full cycle time was about 27 seconds. With a dual gripper, that went down to 15 seconds. So you're saving about 40% of time, which is really a lot of time, which will help you pay off your full application in a much faster time, i.e. a much faster ROI. Of course, you'll minimize the machine idle time. It's still very easy to program, even if it's a dual gripper, and you can handle multiple parts. So with our dual gripper, you have the option of using 2 of the same grippers. In this example here on the Series Cobot, you have a magnetic gripper plus the RD2, but you can also use 2 of the same grippers. It could be 2 3FT15 or 2 RD2s or 2 MD10s, whatever. It doesn't really matter. You can mix and match depending on what makes the best application for your setup. So I think we are almost running out of time. Maybe I'll just show one quick video. Let me show this one. So I don't know if you noticed, but basically what it did, it picked one sheet at a time to the outfeed system, and then you saw at the end it picked up 2 plates at the same time from the outfeed system. So that is, as I said, it's very easy to control. So just a quick recap on our value proposition. So as I mentioned earlier, all our grippers are fully flexible, so you can set the stroke, you can set the force, you can easily change the fingertips, etc., depending on what is needed. So you can basically have one gripper to work with multiple work pieces, either in the same cycle or at different times. So you don't need, multiple grippers for multiple work pieces, but just a single gripper for multiple work pieces. You can use it in a single or dual gripper option. So dual can be 2 of the same or 2 different grippers. It doesn't matter. They're very easy to deploy. Basically, within 5 minutes, you can mechanically attach them to literally any robot. And programming also is very, very easy. And everything is fully electric. So no need to worry about air supply, etc. So very easy to set up, almost no running cost. So if you want to learn a little bit more, you want to spend a bit more time on understanding how to set up a CNC machine tending application or other applications, you can go to learn.onrobot.com and you can see different videos. You can pick different applications you want to learn more about, but go into the website and you can easily understand more about how we support you and what kind of robots we have and what kind of application we work with and what kind of solutions we're offering. So that's it for me. So thank you very much.
Okay. Thank you. Thank you very much, Niels.
Welcome.
Thanks for the wonderful presentation. So as I mentioned, I request all the participants to please have their questions on the chat, and then just after my presentation, we can take it forward and have a Q&A session. Okay, so a quick introduction to myself. My name is Shiv Kumar and I'm the Chief Operating Officer at MELSS. I have more than 19 years of experience in working in the IT and industrial automation space. I come from Temasek Polytechnic of Singapore and with qualifications from Monash University and University of Western Australia. And I've been part of implementing a lot of industrial automation solutions and robotics, and also for a lot of MES tracking, traceability, and Industry 4.0 related solutions. Okay, so that's a quick background to me. All right, great. So today the presentation is going to be focused on robotic machine tending. And to start with, I'll just have a quick introduction of MELSS and what we do. We are an engineering and technology solutions company, and we started in the year 95. We have about 150 employees. We are headquartered in Chennai, and we have our branch offices across all the major metros in the country. And we also have sales and support engineers in other parts to support our customer base around that area. MELSS, we operate in 3 business areas. The first one being what we call as agency, where we represent a number of companies from across the globe in India for electronic testing, assembly, and repair related products. We also provide a lot of solutions for telecom and photonic research, as well as for testing applications. And of course, we represent companies for reliability test equipment such as vibration chambers and Hall task systems. The second business area is what we call as the industrial automation group, where we take up turnkey projects and we implement complete electromechanical solutions, including robotics and Industry 4.0 solutions for IIoT, MES solutions, and anything that has to do with a factory shop floor as a solution. And the third business vertical we have is what we call as electronic systems. Here we build customized electronic solutions for our customers, primarily in the area of testing, but we also do a lot of work in the areas of training simulators, and we work a lot with the defense forces for mill grade applications. Our headquarters is in Chennai, in Perungudi, where we are located. And we are an ISO certified company for both quality management system as well as for information security and management. So talking about industrial automation, we provide complete turnkey automation solutions for discrete and continuous manufacturing process. And internally, we have skills in the mechanical areas, electrical and control systems, as well as the IT and OT space. So as a solution integrator, we are able to provide all that is required to implement a complete automation line, and more specifically in the areas of robotics. Our projects typically start with a conceptualization, be it an assembly line or a robotic automation line or a weighing and batching type of a solution that we can offer. We do a complete 3D model. We work with our customers to detail out how the system has to be set out, where the operators are going to be standing, how they will interact, what is the safety norms that are required, and we come up with a complete solution for the customer. So MELSS, we pretty much work with 4 partners in the areas of robotics. We work with Epson for their SCARA robots. These are 4-axis quick pick and place kind of applications or dispensing applications. We are the authorized partner for Doosan for collaborative robots in India. We work with Yaskawa. We already heard Mr. Alok Pandey talk about the complete range of products that Yaskawa has. And of course, we work with OnRobot for all their end-of-arm tooling and the accessories that they provide as a total collaborative robot solution. So when we look at industrial robotic applications, we broadly classify them in 8 different headings. So as categories, they could be for material handling, they could be for assembly, material removal, for quality related applications, begin inspection or measuring, machine tending applications. This is what we are focusing today on. Of course, for material addition or welding applications, and there are certain ad hoc applications for agro or medical related applications. And MELSS, we work across all these segments, providing solution for different type of robotic applications. Again, when we talk about robotic applications, we do the complete conceptualization. We do the simulation to see how fast in fact, I have a slide further down talking about the overall approach to having a robotic cell implementation. But we do the conceptualization. We see we had both Mr. Alok as well as Niels present about having more than one machine being tended to by a single robot. So we look at all this, including the cycle time, and see how we can offer a total comprehensive solution to meet the specific requirements of the application. So Doosan Robotics, we represent for the collaborative robots, and they offer one of the widest range of collaborative robots that's available in the market. Starting with the head series, which is the high payload series. We've got a 10 kg and a 20 kg and a 25 kg payload cobot with Doosan, and they have one of the highest available safety standards in the market. And it's quite lightweight, the cobot itself, so they can be mounted on moving platforms, and it is easy to handle. They come with a 1700 mm reach as well as a 1500 mm reach variants. So they are typically good for palletizing applications or any application that requires lifting of heavier payloads. The second series is the M series cobots. The M series cobots have specialized safety and force control in them, where you can have force detection of up to 0.2 newtons. And of course, these are very good for high precision jobs. It comes right from a 6 kg payload all the way to 15 kg payloads. And they are very good for critical applications which require high accuracy or high speed functionality. And what's interesting with Doosan cobots is that they come with 6 torque sensors on each of their axes. So that provides very good force sensing capabilities and for a very good safety in terms of collaborative applications. And the A series, which is the economical series, we would say, and quite fast. They are able to do most of the common collaborative robot applications, and they come with 5 kg and 9 kg variants. So this is with the Doosan Cobot lineup. We had Mr. Alok San presenting the complete range of robots that Yaskawa can offer, and they have specialized industrial robots for press handling and machine tending applications. And of course, we have done a lot of projects with them for palletizing applications as well. OnRobot, so MELSS is again a partner of OnRobot for providing solutions, integrated solutions along with their end effectors and other platforms that OnRobot offers. And we integrate it along with the robot and the complete robotic cell. I'm not touching upon too much on the specific tools itself. Mr. Niels has already covered them, and we will look at a little more in terms of the application itself. So when you look at integrated machine tending solutions, so the first thing that we look at is it's just not sufficient to get a robot and then put a end of arm tool and then say that, OK, I can now have a solution running. And that's where MELSS comes into place. So the first thing is most important is to do an application study. So when we talk about application study and more specifically in machine tending, Niels also pointed out that machine tending is typically a high mix, low volume, right? That's the nature of the application, whether it be it a CNC machine, it's a press machine or so on. What happens is very few use cases have only 1 or 2 variants. Many of the cases or projects have a lot of variants that the system needs to handle. They come with different dimensions and shapes that need to be handled. The weight is also important because a lot of the robot selection or the tool selection is dependent on the weight of the product itself. You then also have to focus on the cycle time by implementing an automation or robot. Typically, nobody wants to slow down the output of the machine of what the machine can deliver, right? So you want minimal handling time and maximize the yield from the machine itself. And of course, the accuracy is important. You don't want, depending on the part that you use, you may want to place it in very high accuracy in micron precision, or it could be a couple of millimeters. It's OK. The machine is able to handle it and align them. So it's very important that we study all these aspects before going in for a solution design. The next is the robot itself. So when you select the robot, again, there are different types of robots available in the market. You have right from gantry robots, you've got SCARA robots, you've got 6-axis collaborative robots, you've got larger payload industrial articulated robots. And these days you also have the spider robots and double arm robots. So it's very important to choose the right type of robot for the application. And key selection criteria are selecting the right payload, the reach of the robot, and of course, the speed. So the speed is very important when you talk about what type of cycle time that you are trying to achieve. So it's just not the robot selection as well. It's very important to choose the right type of end of arm tools. And talking about end of arm tools, you've got to choose the type. Again, you have pneumatic operated end of arm tools. You've got fully electric tools. So if you're going to mount something on a moving platform, you may want very less cables or hoses that are attached to your gripper itself. So then the electric grippers work very well in such applications. And they also give you a much better control, like the RG6 or the 2FG7. You're able to set up what's the stroke length. And these are advantages that come out. And of course, choosing the right capacity. When I say capacity is either the payload or the stroke length, and the speed at how fast the gripper can react to the need. So every second counts when you are looking at an overall solution. And it's also important to consider changeover. So if you have many different variants of parts that you need to handle, you want to keep the changeover time as minimal as possible. So the products like the OnRobot gripper comes with a double head model, so you can attach 2 grippers to it, and you also have an easy click on, click off. So this way, the time taken to change over from one part to the other becomes much reduced. And on a typical robotic cell, is just not the robot or the end of arm tool. You have other accessories. You need jigs and fixtures to be able to position, handle the parts that are coming. You also have conveyors, you've got lift or motion. So you may have a seventh axis that is required, including lifting the robot for heighting different reach, or you may want to horizontally move them. There are also situations where the robots are invertedly mounted so that you are able to move it across a flat surface, right? So those are also required. And there are a lot of case studies where you need precision instruments. It could be for making dimensional measurements, or it could be to sense a specific object and then take a decision. And the next thing is to integrate the robot. So it's not, again, the robot cannot work independently. It needs to get integrated with your CNC or the machine that you are working with. It needs to exchange signals. It could be just through digital inputs and outputs, or sometimes it's through some communication channels using a control system. And we also have machine vision. These days, a lot of projects, or when you have more variants with quick changeovers, you may want the robot to be guided by a vision system rather than manually having a fixed program that allows it to reach. And of course, there's a lot of software integration that you may want to do as well. Safety. Safety also is a very important aspect when you talk about robotic projects. The overall environment in which it's working, how much is the footprint that I have? Do we choose a cobot or do we choose a robot for the application? Today, it's also important selection of a cobot and robot on the speed of the application that we are talking about. What's the space available? Are people working next to the robot? That's quite important decision. And of course, selection of the right type of fencing, safety sensors. And it's just not about the human safety. You also have to look at the machine safety, right? You don't want the robot going and hitting some part of the machine which could be moving, and all this needs to be considered. The next thing is, of course, programming the robot itself. So you either program the robot, and they are intelligent end of arm tooling. They need to be programmed as well. Of course, the PLC which controls or handles any handshake needs to be programmed. And today you have tools like the Weblytics and other web software that allows you to look at OEE. And so you may want to do all the integration on these tools as well for your Industry 4.0 implementation. And the last is the support. So when we talk about support, you need service support. It's just not implementation of the robotic cell. You need to be able to handle it for a long time to go. It's an investment that you make. So you need to handle it. And of course, you need real-time monitoring, how the robot is working, or a product like the Yaskawa's YCP helps do that. So MELSS, as an organization, we help you look at all these aspects and give you a total solution, not just individual products itself. So we are able to handle end-to-end for you. So let's look at a few videos, case studies that we have. Let me just stop sharing a screen again. I'd like the audio to come across. First, then it works along with the grinding. So the clearance here, you can see there's only about 100 micron clearance around the part itself. That's what repeatedly plays the place. the part also needs to be So this is another type of an application. While this is strictly not a
Professor Balaman here. Sir, can you mute audio from that video file, sir? I think whatever you're talking, you're not able to listen.
Sure. Okay. Thank you. Yes. So yeah. So this is not a strictly a CNC or a VMC type of a machine, but then you have the robot that has to constantly pick cardboard from a pallet and then keep feeding to the machine. That's about doing 10 or 20 cartons per minute. So sorry, per second. And so the robot needs to be constantly picking up and delivering. Otherwise, it's a high fatigue job. So you can basically talk about it being a dirty and a dull job. So it's easier that a robot handles, and here we have used a Yaskawa robot to do a customized gripping solution to be able to handle these cartons. Okay. So in this case, actually, these are type of parts that keep coming out of a press continuously. And the requirement is that an operator otherwise needs to keep holding up one by one part and start filling them into a box. And this box needs to be stored. So we have a robotic solution here that accumulates each of the part and keeps picking them. Then we create a stack, and then we also created an external racking solution so that the whole system, the operator does not need to come near it for, let us say, half a shift. We can even do it for a whole shift. So the advantage is that without an operator, the entire system can keep continuously running. That gives a good advantage for the overall robotic implementation. So again, as I said, the overall solution, if you see, it's important that the robotic solution is looked at in totality, where we are able to have other accessories such as these racks or conveyors and other solutions that will help in building a solution. This is a SCARA robot based solution that we have. And here we pick and place parts. So this is a typical drilling machine that is available in any kind of a part manufacturing machining factory. So we have parts that need to be placed, and there is no requirement for a 6-axis robot here. So we've used a standard SCARA robot to be able to provide this kind of a machine tending solution. So again, we have two heads. So the advantage is that while one part is being operated on by the machine, we are able to pick up another part, complete it and be ready, so that the time spent by the machine robot during the machine operation is being utilized to the best possible extent. All right. Okay, so moving forward, so those were some of the machine tending type of applications that we can offer. And as you see, it's a full solution that we do along with the safety, fencing, and whatever is required. We also do solutions for palletizing. So the robots come with a lot of palletizing tools these days. OnRobot also has a specialized palletizing software that can enable you to quickly program a palletizing cell with different type of configuration, and then we put it together. MELSS, we have also built larger robotic cells with for, let's say, palletizing of bags and so on. This could be very good for standard large scale applications where we are doing the palletizing solutions, right? And integrating with some bag printers, line printers, or labeling machines, and then packing machines. A slight deviation. So MELSS, apart from providing solutions in the robotics area, we provide solutions for bulk material handling. These are for powders and different type of powdered material, typically in the areas of cement, refractories, ceramics, and these kind of industries. We also provide, so these are some photographs of the different type of installations that we have had, handling the jumbo bags and so on. We also do a lot of unit handling solutions. These are all part of our turnkey project offering, and many times the robots are also used here for, let's say, for palletizing lines. So here different type of conveyors, turntables, scissor lifts, and pallet dispensers, anything that's required to do a material handling application. And some photographs of the type of works that we have done. We also have specialty in providing end-of-line testing solutions. So we provide functional and endurance testing solutions. These are for specific applications where you don't have a standard machine that can support in this, but then we provide the solution for all type of different instrumentation. Some of the solutions today come with vision as well. So we integrate that and provide a total turnkey solution, be it electronic signal measurement or it's a dimensional measurement. And these days, a number of the projects that we do in end-of-line testing are also integrated with robots. So there is no human intervention that's required to do a continuous end-of-line testing. So it may not just be a sample testing. It could be for every part that comes on a production line that needs to be tested. And a robot is very good application to deploy for such things. Okay, some photographs of the different type of end-of-line testing solutions that we have offered. And of course, being in the automation area, we provide complete control panels, PLC driven with VFD servo and whatever is required to implement the overall automation. And Industry 4.0 plays a very big part in terms of project implementation these days. Almost no company looks at a automation solution without Industry 4.0 compliance or being fully able to integrate to their monitoring systems. So we provide complete tracking traceability solutions, including all barcode or RFID based solutions. We have real-time manufacturing monitoring solutions for OEE or energy monitoring. We do mistake proofing solutions and Pokayoke. And we also do the ERP and third-party product integration that may be required to talk to your machinery. So we have the complete skill sets of providing the MES solution, all the visualization and real-time data. And finally, we also have our own capabilities to provide IIoT solutions to our customers, right from the field sensor level all the way to the visualization. So if any kind of data needs to be collected or you need to do a machine-to-machine communication, pass information from your press or your CNC machine, we need to take this data and then we need to pass it on to the robot or send it to your server. So we can do that. We've got a wide range of IoT products right from IoT-enabled NFC reader. So you want to do part detection or do a validation for mistake proofing, we can do that. We have edge gateways in 6-time Atom. We also have a very interactive touchscreen display for IoT kind of rich communication applications. And we also have a product called the Edge Box, which is very good for part traceability, mistake proofing, and OEE type of applications with on-screen buttons and a wide variety of communication protocols available on them. We work with a wide number of customers. Some of the popular known ones are here across different industries. These are for general automation solutions, robotics, as well as some of them we have implemented the machine tending solutions here. MELSS, while we are primarily present in India, and over the years, we have deployed our solutions in over 20 different countries. So we've got a global experience in terms of deploying solutions and supporting them as well. And that's the end of my presentation. Thank you very much. I'll now open the session for question and answers. Thank you very much. Yeah, if any of you have queries, feel free to unmute yourself and ask the question, or there's something you can also put it on the chat box. Okay.
Could you please let me know, is OnRobot are available to support or provide any solution for spot and stud welding specifically for automotive industries?
Okay, if I understood your question right, so Niels, you can answer, but I think the question was, does OnRobot provide solutions for welding applications, right? And
stud and spot welding.
Yeah, so okay, so basically what OnRobot is, we are working with collaborative applications, right? So when we talk about collaborative, one of the key things with being collaborative is safety. So one thing we will not go into is welding tools, because basically it's not safe, it's not collaborative, right? However, we are supporting some welding applications, but basically with our grippers. For instance, we have clients that are using either 1 or 2 grippers to hold metal items together while they're being welded. So that's one way we can support, but welding tools as such is not something we are doing.
Right. Okay. Thank you.
Thank you. Okay, we have a question from RP Hola. What are typical return of investment in Indian manufacturing scenario? Okay, so we have had different projects that we have implemented. Okay, we'll put it this way as well. So not all projects are focused on a return on investment only from the basis of manpower. While today a major focus seems to be that sometimes there are applications that just cannot be done by humans. It's dangerous. You handle hot products, they are dangerous products, or sometimes the fatigue is a big problem. You carry heavier payloads, or there are also, let us say, critical applications where quality is important. So you have dispensing kind of applications, or you have precision insertion applications. And in these cases, what happens is the return on investment calculation is slightly different, because if a human is put on this job, the replacement costs are very high, or mistakes, then the wastage created is very high. So then those become your benchmarks to calculate the return on investment on your project. But purely going by a return on investment, most customers that we work with normally have a 2, 3, or sometimes up to a 4-year payback calculation. Many times it's 2 years, but it can be up to 3 to 4 years for more complex applications. But it really is a balance that they'll have to do, looking at manpower replacement costs, and the other is from the type of applications that I talked about. I hope I answered your question.
Yeah, hello.
Yes, please. Yeah.
Yeah, so my question was that a robot, you have your own controller where you can do the programming. The second interfacing you can done in case of CNC tending machines. For example, you can take some data from that controller and you can, synchronize your robot. Now my question is, suppose CNC machine is there where your robot is doing tending. Assume there is an assembly unit besides machining assembly unit, and there something goes wrong. For example, if assembly line something goes wrong, something. So can we give some data from there and put into this robot so that in advance we can control the robot here?
Yes. You're talking
Or
about.
my question is I mean I confused you. My question is your robot is having controller. You have your own program. You can interface with CNC. Now my question is, can we give some data from anywhere of other equipment to control your robot?
The answer is yes. We'll have to look at the application, but okay, if it's a simple information like, okay, you stop the robot, don't process for some time because of line balancing type of thing. These are very simple integrations that can definitely be done. It could come from anywhere, right? So that's definitely possible. But if let's say you want to do some correction in the robot, let's say it has to change some coordinates for some purposes, it's still possible. All these robot controllers these days come with, for example, if you are using a Yaskawa robot controller or a Doosan robot controller, they come with options for us to communicate through different protocols. It could be Ethernet IP or a Profinet type of a communication. We are able to communicate. You can send signals to change the offset points as well. So that's something that's very much possible. And depending on application, we can do those interfacing. It is possible.
So my last question to you is, in the beginning of the presentation, you have some 3D plans,
Yes.
While preparing the projects. Can you elaborate on that? What is that actually?
Yes, so there are quite a number of 3D tools available today for us to prepare the actual layout. So much so that, let's say, we use standard CAD packages like SolidWorks or something is there. We have simulation tools like Yaskawa has a product called MotoSim. You can use something like that to simulate. We have visual components. We have different type of tools where we are able to build the entire line, and you can set up different objects that are on it, see the reach of the robot. Depending on the type of robo model, we are able to see its reach. And normally any application, what is the footprint that is available, right? And how many machines it has to tend. And then
normally I've seen this 3D kind of.
Sorry.
Normally, sir, I have seen these 3D models in big EPC projects where we put all the 3D model and we do the layouting. Where is the heat exchanger? Where is the pressure vessel? Where is the reactor? Where is the staircase? So same way you are using this 3D to program to do the solutioning for your this?
Yes, very much. We definitely put it on 3D. So the chances of making mistakes when you implement the project is significantly reduced because any project, when you visualize it in 3D, you know exact positions of where things are, and you're able to design the gripping tools, and manufacturing of the parts also becomes much easier. Yes.
Sorry, my last question to you. We were talking only about function. If we have, every company has a ERP product. Okay. So suppose if your robot is working in particular molding machine and there is a cost involved into that. So every product, every machine has a ERP system. Every company has an ERP system. Can we push some data from SAP to your robot and we can calculate cost, or can we add a cost angle to your robot where your robot can, apart from doing automation, they can also tell us what is the cost of that particular station of production? Or it will be too complicated?
I wouldn't say it's complicated. I think based on the bill of material, your ERP would already know what's the cost of producing a component.
Exactly.
Yeah, the robot can definitely report back saying it has manufactured X number of components in a shift or in a period of time. And I think then we put one more software in between to do the cost calculation and push it back to the ERP. That's possible.
So this is really my last question. What sort of reporting? What sort of reporting we can get from the robot? Reporting. Apart from production and everything, what sort of the reporting which can control the manufacturing process? If I'm heading the plant and I'm looking at my laptop, what sort of controlling report
Yes, so maybe Niels, you can talk about Weblytics on this. I guess that's something that would interest.
Yes, I mean,
Yeah, Mr.
Hello?
Yes, Niels, go ahead.
Okay, sorry, yeah. So, I mean, so basically with Weblytics, you can kind of easily go in and set up
Yeah,
your own.
yeah, I can hear you, sir.
Yeah, okay. So with our system, for instance, you can go in and actually set up your own parameters to a certain degree, but it depends a bit on what the robot offers and what the specific end effector offers. But as I said, for us, it's not highly complicated. It's more like, for instance, what is the cycle time? How many pick and place do you do in X hours or X days or X weeks? And you can also compare, for instance, day 1 to their day 2 or week 1 to week 2, and so you can see parameters on on each shift, whether it's a day shift, whether it's a night shift, for instance, things like that. You can go in and look at as an example. So these are some of the things you'll get feedback on from Weblytics, for instance. You can also see. Has there been, how many times have you dropped, for instance, a product? How many times has the robot or the application stopped? For how long has it stopped? So these are some of the feedback you will be able to get.
I think Shivakumar, I will connect you. A little bit questions are there. I think this forum is not correct. I will ask you separately.
Yeah, please do. Yeah.
I think Shivakumar, I think one thing that's important also is that it's fine having the 3D setup of how the application is going to look at and all that, but ultimately in my experience and in my opinion, I think one thing is important also is to always test, and sometimes without having to build everything, you can do a simple test. I mean, it could be, you're talking about plastic molding, for instance. You want to do a simple test. How are you going to pick up how fast is the cycle time? So between MELSS and between us and potentially between Yaskawa, we can be able to set up a demonstration even in your factory. To you can see how is it actually going to work, how fast is it going to be, how easy is it to pick up, for instance, different products and so on. So that is something we can assist with as well through MELSS.
Yeah. I'll ask, connect you.
Sure.
Thank you very much.
Yeah. Thank you, Mr. Vijay. Yeah, I think.
Good afternoon. My question again is for Niles.
Hello. Hello, Pandia.
Are you hearing me?
Mike,
Yeah, okay, we'll just go one by one. Maybe, yeah, we have Mr. Balasubramaniam who's raised his hand. He has a question. So
yeah,
please go ahead.
Balasubramaniam here. Good afternoon.
Yeah.
Yeah, we have multiple CNC machines.
Mm-hmm.
For that selection of automation, robot or gantry. So which one is appropriate one?
Okay, maybe Alok San can answer this, so I'll let him do that. Yeah.
You are having a multiple machines and you would like to know which kind of automation will be okay, like gantry automations or robotic automation.
Correct.
So there, of course, multiple things are there. When we go as the basis of your machine is not dedicated to the part. If your machine is dedicated to the part, only one single part, and if there is a feasibility of gantry automation, you can go for that. But when you are going to use in future your machine for any other kind of product or futuristic product, any other thing is going to change, or your machine is common, because your machine is common, you are changing the fixture and just going for the second kind of model or third kind of model or fourth kind of model. So in that particular case, I feel you should go with the robotic automation. And if you are having a sufficient cycle time, then in that case, you can mount a robot on invert, and then you can move one place to other place for multiple machines, and you can do the handling with a robotic automation if cycle time permits. If you are having a very quick cycle time, like within the two machines, you are having a 20 machine, and within each machine having a cycle time of 15 second or 20 second, then I feel you may have to go with the gantry. But if you are having a cycle time between the 8 machine, you have a cycle time approximately 3 minutes or something like this, then is better you can go for robotic automation, because one robot can able to serve the all machines.
Our machining time is varies from 20 seconds to 30 seconds.
20 second to 30 second. Yeah, so 20 second to 30 second, there is something like this, a complete line. Either you have to go for the, like in 2 machine, you have to place a 1 robot. So that kind of automation you have to place it, like with 2 machine, 1 robot. That's a normally cycle time is there with that. And if you are having a variety of kind of product, then of course you have to go with robotic automation. If you are having a fixed product and you are sure in next 5-6 years your part is not going to change, then you can go for gantry automation. And also you can go for the mixed production, like few machines with the robotic and few machines with the gantry. Because as I talk about my robot, in the my robot can work with like 2 machine for robot, and the same robot you can control 3 extra motors, and you can make a gantry with our motor which can be operated with my same robot controller. You don't require PLC for that. You can control my motors with my robot controller, and then you can able to make a gantry also with that.
Okay, thank you for your clarifications.
Thank you. Yeah, Mr. Mohammed, please go ahead, Mohammed Fatma.
Actually, my main question is for Niles on robot.
Yep.
Right. Could you please let me know which gripper is from OnRobot package is suitable best for handling glass small vials for medical devices industry? Actually, we are currently working in Pakistan for Unilever, P&G, and Abbott, JSK, and many multinational industries on different applications. So we have an application of handling of glass vials. Could you please answer me, Nice? What suitable gripper did you recommend? Could you recommend us for that application?
You mentioned glass, right?
Glass vials, small glass vials.
Yeah. Okay. So the RG2 gripper. So this is where the flexibility comes into place, right? So the RG2 gripper we have, you can set a force between 3 to 40 Newton. So if you go down to 3 Newton, you can basically pick up an egg, for instance, without squeezing it. So that is where you can fully control how much force you need to pick up, and glass, it might only be 5 or 10 Newton, or things like that. So that's a perfect gripper for that. But it also depends a little bit on the environment, right? So our RG grippers are not what do you call it, clean room certified. Only our 2FT7 is clean room certified. So if you need clean room certification, then maybe the 2FT7 is just the force is a little bit higher. So that's where the testing comes into place. We basically need to test, and also depending on your scenario, is it clean room? I said not clean room. If not clean room, then for sure the RD2 gripper would be the optimal for you, especially working with more fragile items.
Okay. Could you let me know what is the cycle time to handling a single vial or multiple vials with RTG gripper? Did you just say?
Good question. Branson, are you there? I don't know if I can't remember the specific maximum cycle time.
Rough idea, a rough bracket.
Yeah, sorry.
Yeah, Branson, do you recall that?
Sorry, what was
the cycle time, maximum cycle time for IG2, full open, full close?
Maximum cycle time.
Yeah.
I think we do not really state it because it depends on the force that you're using. So
Sure.
the speed is a variable, so we do not have a fixed cycle time for this.
Yeah, not with RG gripper anyway. So basically for the RG gripper, how it works is that the higher the force, the higher the speed. The slower the force, or the lower the force, the slower the speed, which is also to do with safety. Whereas if you use the 2FT7, the parallel gripper, you can basically control the speed on it, but the minimum force is a lot higher. So again, that it comes down to testing whether the minimum force is still able to pick up your item without spoiling it.
Right. All right. I will separately contact you regarding commercial terms for this gripper, and we want to order it from you. And inshallah. Right.
Sure. You can contact MELSS as well, and if any testing needs to be done, we can work with them on that.
Okay, interested. Okay. Thank you.
Welcome. Sorry, Shiva, you're on mute.
Sorry. Yes, Mr. Balamurugan, please go ahead.
Sir, good afternoon to all. Good afternoon here. I think this question belongs to Mr. Alok Pandey, sir. Hi, sir.
Yeah, hello, sir.
Sir, regarding that already you aware that we are using 4 Cobot, right? Has C10DTP in ATS Motor Company Limited.
Yes, sir. Yes, sir. Yes.
So here we are having some conflict between that product catalog and actual that see what I was saying that in the product catalog is showing as a collaborative mode 1000 mm per second. I think you are aware this, right? So currently we are running, sometime we are running 250 mm per second as well as for 800 mm per second also we are running. Sometime we are facing frequent PFL alarm and as well as collision also is there. I think that is how to overcome in future projects. Not only here, that some other and also they'll face same issues. How to overcome these issues? I think we finally found that 250 mm per second only recommended from Yaskawa. That given as a catalog safety preconditions, something blah blah weddings. So we are finally stuck and we are having some issues. So how to overcome in future?
Yes, sir. Actually, this particular case, I just want to upgrade you. Like whatever the robot you are using, that is I think SC10 robot. Okay, and SC10 robot, whatever the in the cobot, whenever we are using the gripper should have an internal routing. I think that gripper in that particular robot, you have routed a plastic hoses from outside. Right,
yes.
Plastic hoses from outside. One thing is that there, whatever the gripper is there, I think that's a normal gripper. This is not for collaborative mode gripper. Second thing.
Yes.
Third thing is there, robot can work on 1000 mm per second if we have properly defined the force parameter and load parameter.
Okay.
Robot can work. Now what happened? Why logged 250 mm per second? When your gripper is not collaborative, your environment is not collaborative, then 250 mm per second is a no robot. When robot and manual mode, robot can work together. That's a particular case, then we will define 250 mm per second. If any customer want to go more than 250 mm per second, then there is a third party safety companies are there. SICK is there, PILS is there. From that, proper certification is required whenever we are increasing the speed. Because whatever the tool we are using the normal tool. We are not using the collaborative tool. Without collaborative tool, if we are using traditional tool, there should be a safety certification taken from the third party. Then only you can run cobot with the more than 250 mm per second. If you are using traditional gripper, then it should be logged with 250 mm per second. As per safety consent, no one will confirm you should run more than 250 mm per second. Normal company will inform that only. If other company have told you something like this, robot can go on 1000 mm per second speed also. I will give simple example. If you are having vacuum gripper and that is also with collaborative sensor, you define the robot and you run on the 1000 mm per second, it will work. There is no problem. And it will work in the collaborative mode, but it should be certified by the safety agency. Then only it will be collaborative mode. I have seen in India everywhere, even 98% to 99% cobots are working, but actually they are not working in the collaborative mode. And that's why Yaskawa has logged the speed to 50 mm per second, because robot accessories is not collaborative.
Okay.
Okay, sir.
Sir, I think next question to OnRobot team, sir, I think. Yes, sir. So I think we go seen some n number of polishing, right? Polishing applications worldwide in YouTube as well as LinkedIn and so many Facebook videos.
Yep.
So we are having one problem. I think you are aware. I think Shangaramuthu contacting regarding these issues. We are having some issues with respect to that complicated shape, look like fuel tank, and as well as the style parts. So what will be the better solution on this for this problem what you are facing?
I mean, it's a bit hard to answer without actually seeing exactly what shape you're talking about. Generally speaking, I mean, we have clients in India as well that are using our polishing tool in the production with shapes also that are curves and different shapes and so on. So generally speaking, when it comes to that, typically what we do is we include our force torque sensor. So the force torque sensor is, I mean, it's not only about controlling the force, which often is important in both polishing and sanding, but it's also on the torque. So you need to, when the polishing tool is moving around, it controls both the force and the torque. So that's basically how we control it. So again, ultimately testing is always important. But as I said, when it comes to curved items, that's where you need a force torque sensor. The robot itself, it's very hard for it to control it without having a force torque sensor used. So that's typically how we overcome different kind of shapes. I don't know if that answers your question.
Palmudin, you're on mute. Is that okay?
Yes. Sir, is there any specific robot compatible will be right on robot with respect to universal robot or some Yaskawa Cobot? Is there any specific some models or some make will compatible with only particular robot like this? Is there any complication on this on robot grippers?
For grippers, if you just talk grippers, it really doesn't matter. Any type of robot, it doesn't matter whether it's a cobot or industrial robot or Yaskawa robot or whatever. It really doesn't matter. It's just a matter of how you integrate, right? So it could be Ethernet IP, it could be digital I/O, it could be Modbus. So it depends. It depends on the robot type. When it comes to the polishing tool, same thing. You can basically use it with any robot. However, when it comes to, at the moment, when it comes to the force torque sensor, we integrate with UR, TM, Omron TM, and certain KUKA models. That's how it is now. However, by beginning next year, it really shouldn't matter any of our what we call compatible robot brands, and that goes for Yaskawa, Doosan, all the major robot brands. We will be able to integrate the force torque sensor as well.
Yes, sir. Thank you.
Welcome.
Thank you. Yes, Mr. Mohammed.
Right. Again, for Niles, actually, we have an application of quality inspection in a leading automotive car manufacturing industry. The application is inspection of gap or something like quality in completely manufactured car by Cobot. Could you please suggest me is your the eyes the gripper eyes are provided by OnRobot is suitable for that application or not? Is it applicable to online inspection and upload data on a PC or something like that, or we move on to another robotic or something different application vendors?
It was I don't know. It was a bit hard to hear exactly what the application was. I heard inspection, but of what exactly? Sorry.
Completely car manufacturing industry. The final inspection of a car.
Panel inspection.
Right.
So again, it depends a bit what you want to inspect. So we do have an inspection feature, but I guess panel inspection you're talking about. As I said, it depends a bit what you need to inspect, to be honest. Right. So Branson, maybe you can explain more on exactly what inspection features we have in place, if you don't mind.
Yeah, hi. So the inspection feature for Vision, actually, we do have inspection for the outer contours or the inner features. So I think outer contours pretty much is very straightforward. So we just inspect the outline of whatever workpiece that you're going to inspect and check for any defects. And for the inner features, it's for example, if you have a plate with a through hole in the center, for example. So with the inner feature, we can actually inspect the hole instead of the whole workpiece itself. So that's how the inspection works for the outer contour and the inner feature itself.
Right. If you have any video or of the application doing the same task of inspection of car manufacturing industry,
we don't have specifically for car industry. Not that I'm aware of. So certainly not in the region I'm covering. But again, I mean, what I normally suggest, and in fact, MELSS, they have one of our cameras with them. so they can also help you if you want to do a test on it. So that is something we can arrange as well.
Right. Okay, thank you.
Thank you. We'll get in touch with you, Ms. Mohammed. Yeah, and then we'll see you. Okay. Okay, there are two other questions on the chat. So there's a question. Okay, it says guest. I don't have the name, but I think Alok-san can probably answer this. It says, considering high temperature and high humidity with respect to Indian climate, how do you ensure that robot electronics, motors, controller work?
Yeah. So when we talk about the controller, so controller used to come with the IP54 protection, and if door is closed properly, and if whatever the electrical connections we are doing with the proper conduiting, and we are not making any hole open, then there's a IP54 protection already available. And for any kind of harsh environment and all thing, already in the controller, if you see whatever controllers are there, 50% of space of any robotic controller is covered by the cooling fins. So there is a cooling fins and fans are there who is continuously cooling down the things. So inside, if outside whatever the temperature is there is not going to matter, inside the temperature is maintained by the robot controller, and they are continuously cooling fins is dissipating the heat outside, because 50% of robot controller only for this particular purpose where cooling fins and fans are there. So this is doing, and after cooling fins only this IP protection start working. There only IP54 protection is there, but of course your robot door should be closed. If your robot controller door is not closed, then it will be harmful for you, for your robot in future. Now second, I comes for the cable and all things are normal. It's already comes with a protection level of dust and waterproof. But when it comes for a robot manipulator body, robot manipulator, when we talk about our wrist and body, it comes with the like wrist, our IP67 protection is there. So against harsh environment, that protection is there. Now only left out whatever the cable is laying on the manipulator side. In that particular case, if any harsh environment means in term of the heat, the particular temperature is approximately is crossing 80 or 90 degree. Then we have to understand and we have to cover the cable with a heat. The heat circuit is there. So with a heat coating, we have to cover the cables. So that take care, we have to take care. And robot is available with a different protection. So we used to come with a dip proof protection in our robot, which is actually applicable for the foundry and forging environment.
Great. Thanks, Alok-san. I hope it answered his question. So if there's anything else, feel free to get in touch with us. There's one more question from Deepak Lonari from Pune. He asked, do you provide robotic solution for high mix, medium volume type of electronic manufacturing companies? Yes, we do. We already work with different EMS companies, so we can definitely understand your requirements and maybe look at a solution for that.
Okay, thank you.
Thank you. Okay, I think we pretty much answered every other question on the list. Does anybody else have any questions or? Okay, if not, I suppose you have all our contacts. We will be circulating a mail with a recording of this webinar as well, and then you can get in touch with us. I thank all of you very much. Yes, I will. Yes, Mr. Tiwari, I will send my message. I will put my email address and my phone number on the chat, so you can refer to that. And yeah, I thank everyone. I thank Niels. I thank Mr. Alok Pandey for being here and presenting us, and the whole team of OnRobot and Yaskawa. And I thank all the participants for having spent their time with us today. Feel free to reach out to us, and we look forward to working with you. Thank you once again. Have a great day.
Thanks, Shukuma. Thanks, everyone.
Thank you.
Thank you.